Yours.
Hello everyone, I'm Mawara and I'm a doctoral researcher at Aalto University, Finland. And today I'll be presenting my research work, which is from idle to active, optimizing equipment utilization through BLE-based indoor positioning system. To start with the background, the construction sites are dynamic and constantly changing with equipment, tools, and worker moving all over the place. In this environment, efficient resource management is a challenge, but it's also essential for maintaining productivity and cost controlling. As Speaker Duggar puts it, if you can't measure it, you can't improve it. That's why we turned to the listed indoor positioning systems, for example, BLE beacons, Bluetooth Low Energy, Wi-Fi, RFID tags, ultra-wide bands, and many more like that, to track the assets where GPS falls short for the indoor positioning. We selected Bluetooth beacons because they are affordable, low power, and ideal for long-term tracking of mobile equipment. So the construction site often faces a major problem that the equipment sits idle for a longer period of time or even get lost on the site. And the site staff is mostly unaware of it. This leads to unnecessary cost and inefficiencies. The traditional method for tracking are often manual, delayed, or simply not feasible for the complex sites. So what we need here is a real-time visibility into what our equipment is doing or maybe not doing. So the BLE beacons have already been used in research focused on proximity detection and worker safety. However, their potential for equipment tracking to improve utilization has still need to be explored. That is the gap that we are trying to fill here. The goal of the research was to build a system to track real-time movement of the equipment using BLE-based IPS, alert the users when equipment is underutilized or maybe not utilized at all through a dashboard system, and help the planners in resource optimization and reduce wastage. By tracking the movement, so keep in mind that it's only done by tracking the movement-based resources like tools, equipment, and temporary asset. We can identify underutilized equipment, reduce idle time, or make data-driven decision to boost overall site efficiencies, and that is the motivation behind our research. So this system consists of 4 components. First one is the BLE beacon that is mostly placed inside the moving equipment. And then there are gateways, which are Raspberry Pi with a Wi-Fi dongle that are placed all over the site to the predefined locations, and that catches the signal from the BLE beacons. And then there is a cloud database, and lastly, there is a user dashboard. To go more deep into the methodology, this flowchart outlines the steps. First, we collect the data from the BLE beacon through the gateways. Then we and then we send them to the database. Then we clean the data to remove noises or any non-working hours. Next, we analyze it to detect the idle time and send the results to the dashboard system. Finally, the system sends alert if the user to the user through the dashboard system if the equipment remain idle for a longer period of time. Otherwise, simply a report is generated. So we tested this idea on a real 8-floor construction site that used multiple hoists for ceiling installation. That site was located in Helsinki, and that was the sports arena. So the management has a hunch that there are some hoists which weren't being used effectively, and they were right, because the system provided a solid evidence to back that up. To explain more about the data cleaning process, we defined the working hours from 7 a.m. to 6 p.m. We removed the weekend and off hours because the hoists were not used at that time, so obviously they will be idle during the weekends. And we also had some missing values and missing data, so we filled the gap using Zhang's heuristic. And then we also defined some detection logics. For example, if the hoist was not moving for X amount of time, the hoist was flagged as idle. And this amount was already defined by the user itself. And when the threshold was reached, the alert was sent to the dashboard. So to going to the results, this chart shows how much time each hoist spent idle. There were a total of 5 hoists that we tracked in the system. As you can see, the hoist number 160 had a worse utilization, which is 72% of idle time. On the other hand, there was another hoist with code 168, and it was used really well, and it had only 18% of idle time. This kind of insight is really valuable for the site managers. So talking about these two hoists, first of all, this is the line plot that shows the frequency of movement over the time for the hoist number 160, which was placed on floor 3. So here you can see in the starting 1.5 to 2 months, there was no usage as there is no frequency noted. But after that, there were few frequency of movement noted, and it was the maximum usage for that hoist. Another idea to represent this value is through the heat maps. So this heat map shows where the hoist spent most of its time. The darker zone means that there was more presence. This is hoist number 168, which was utilized more, and it moved around regularly, except for only one point where it remained for a longer period of time. These visualization helps you to understand the pattern at a single glance. So this is the user dashboard. It's designed to be visual and simple to use, even for the non-technical users. You can switch between equipment. For example, here you can see that you can select the hoist number and look into the insights. You can also look into the line plots and heat maps for the selected hoist or equipment. And the system also sends the alert when something has been idle for too long. You can see the yellow colored warnings. And then there's a summary for all the equipment that is used. So the idea is that this dashboard can be easily scaled by adding new devices, just by adding the beacon ID to the system. So beside this hoist, this system could track ladder, vacuum, pumps, or anything that moves. And with real-time data, planners can reassign underused equipment or move them to maybe another site. Going forward, we can integrate AI and machine learning to predict usage pattern and improve decision making even more. To wrap up, the BLE system offers a low-cost and high-impact way to track indoor equipment. However, this method can be used with commercially available indoor positioning system that are maybe more accurate. It is real-time customizable and highly scalable. By reducing the idle time, we not only save the cost, but we also improve the workflow and the project outcome. And if we have a good amount of data, we can say that it can also be used for intelligent automation. Thank you so much for listening. Let's connect through LinkedIn, and if you have any question, I'm ready to answer.